Assalamu alaikum. In this video recording, we shall discuss about dispersion or different measures of dispersion. If you have subscribed to this channel, I assume that before this lecture, you have already listened my previous two lecture about measures of central tendency. A statistic is about organizing the data, collecting the data, organizing the data, presenting the data, interpreting the data, and then analyzing the data. Uh, as far as raw data is concerned, it is not very useful for decision making. Therefore, we need to perform some calculation on that raw data to convert it into frequency distribution or into a meaningful information which can be used for decision making. These calculations include measure of central tendency, including mean, median, and mode. And these calculations also include measures of dispersion. So the first question here is that if we have the data of measure of central tendency, then what is the need of measuring the dispersion or spread in a data? So dispersion, spread, or deviation, all these three terms mean same thing. And their opposite is a clustering. So the first reason of studying the dispersion is that a measure of location such as mean or the median only describe the center of the data. It is valuable from that standpoint, but it does not tell us everything uh, which is required for the decision making. A best example for the need of studying the dispersion of data is that if someone asks you to cross a river on foot, a river whose average depth is 3 feet. Obviously, we are not going to cross it. We need more information. What is the variation in the depth? If height of a particular student is 5 feet and average depth of a river is 3 feet, now mean is there. But to cross that river, we need additional information that, okay, mean is 3 feet, but at some place it may be 10 feet or 12 feet as well. Therefore, to make decision to cross this river on foot or not to cross it depends not only upon the mean but also depends upon the variation, what we call it dispersion. And the second reason of studying dispersion in a set of data is to compare the deviation or spread of one population or sample with the second population or sample. So basically, there are four measures of dispersion, and these include range, mean deviation, variance, and standard deviation. The formula of range is largest value minus smallest value. So if we have a set of data consisting of 5 values or 10 values, we will subtract the smallest value from the largest value and we shall call it is a range. So higher the range will be, higher will be the dispersion or deviation or spread, and lower the range will be, lower will be the dispersion. The second very easily used measure or easy to calculate measure of dispersion is the mean deviation. In short, we denote it by MD, and we calculate it by subtracting the mean value from each value of x and then using the absolute values, and we add them up and divide it by the number of observations to find out the mean deviation. So mean deviation is basically average of sum of absolute values of deviation of each value of x from the mean. Then there is a variance and a standard deviation. Now this formula sigma square is equal to sum x minus mu square divided by n. Now let me compare these different measures of dispersion here. The benefit of range is that it is very easy to calculate. Therefore, we calculate it and report it. And it is very basic measure of the dispersion. However, the disadvantage of range as a measure of dispersion is that range does not include all the values of a data set, as its formula tells us that only two values are included, the largest value and the smallest value. All the values lying between the largest and smallest values, they do not play any role in the calculation of range. So to include all the values in the calculation, we use mean deviation. So mean deviation includes or incorporates all the values because here x means that x1, x2, x3 till xn. So mean is subtracted, which is x bar, is subtracted from each and every value of x. Thus, we can say that mean deviation includes all the values in a dataset in its calculation. Now, the limitation of mean deviation as a measure of dispersion is that it uses the absolute values, and using the absolute value may not be meaningful or useful for decision making. Therefore, after range, we can also say that there are some limitations of mean deviation, and it is also not a perfect or very good measure of dispersion. Then we move towards the variance. Now see here, in variance, absolute values are not used. Instead, we square the deviation from the mean. So x minus mu, where mu is the mean of the population and x is a set of data. From each value of x, we subtract the mean of the population and then we take their square instead of taking their absolute values. After taking the square, we add all those values and divide it by the number of observation and we get the variance. So the benefit of variance over a range is that like mean deviation, it includes all the values. However, benefit of variance over mean deviation is that unlike mean deviation, it uses the square of deviation of each value of x from the mean instead of using the absolute value. Why do we take the square? Because if we do not take the square of x minus mu, positive uh, values and negative values may offset each other and we will end up with 0 as a measure of the variance. So to overcome that problem, that positive x minus mu can be positive as well as can be negative. So to avoid that problem of cancelling each other, we take the square and when we take the square, negative values also become positive. And if we measure the standard deviation, then we will simply take the square root of this formula, then it will be known as standard deviation. Now the limitation of variance is that when we use variance as a measure of dispersion, its units cannot be interpreted because we have taken the square of the deviation of each value of x from the mean. Therefore, to offset the effect of this square, we take the square root in the calculation of a standard deviation. One thing more you should know here, that when we do this calculation on the basis of population variance, then we divide it by the n, but when we calculate the variance of the sample, then we shall divide it by n minus 1. Now here you can see the population standard deviation denoted by sigma. If we take the square of sigma square, it will be sigma, and if we take the square of the right side of this equation 3.8, we will get it the square root of sum of x minus mu square divided by n. So when we take the square root, this square effect in the calculation of variance is offset, and we can easily interpret the standard deviation value. Again, here, please remember that in the calculation of standard deviation of population, we divide the sum of square of deviation by n, and if this will be the variance of the sample, then we shall divide it by n minus 1. Now let's discuss examples. The number of cappuccinos coffee sold at a particular location between 4 and 5 p.m. for a sample of 5 days last year were 20, 40, 50, 60, and 80. On day 1, 20 cups were sold. On day 2, 40 cups were sold. On day 3, 50 cups. And on day 5, 80 cups were sold. If we are asked to find out the range, we know that the highest value is 80 and lowest value is 20. So 80 minus 20 will be the 60. So 60 is the range of this data set. Next, here we have the example of calculation of mean data using the same data, that number of cappuccinos sold daily 20, 40, 50, 60, 80. To find out the mean, first of all, we need to find out the mean value. We add up all these values. Answer will be 250, and 20 plus 40 plus 50 plus 60 plus 80 will be 250. We divide it by the 5, so the mean value will be 50. Then we subtract this mean value x bar, which is 50, from each value of x. So 20 minus 50, 40 minus 50, 50 minus 50, 60 minus 50, and 80 minus 50, and we get x minus x bar column. This one minus 30, minus 10, 0, 10, and 30. We use the absolute value, just ignore the sign of minus, convert it into positive, and we get, when we add them up, we get the value equal to 80. As total there were 5 days, so n is equal to 5, so we will use this formula, that sum of x minus x bar divided by 80 minus 5 is equal to 16. So 16 is the mean deviation. This is how we calculate mean deviation. Then the next calculation is about variance. This is the data of traffic citation used during the last 5 months. And these are 38, 26, 13, 41, 22. First of all, we will calculate their mean. So mean of the population will be sum of x divided by x. If we add all these values, we get 140 divided by 5 is equal to 28. So mean value is 28. Then we subtract this mean value of 28 from each of the x values. So 38 minus 28 plus 10, 26 minus 28 minus 2, 13 minus 28 minus 15, and so on. Then we take the square. Like mean deviation, we do not use the absolute value. Instead, we take the square of the deviation. The square of 10 will be 100, square of minus 2 will be 4, and so on. After taking the square, we add them up, and when at the end we divide the sum of this square of deviation 534 over n, which is number of observation, total 5, 1, 2, 3, 4, 5, and we get the variance equal to 106.8. However, this 106.8 cannot be interpreted, therefore we prefer or use the standard deviation. Now this is a case of variance of the sample. The only difference in the variance of the sample is that we divide by n minus 1 instead of dividing by the n. This is the hourly wage rate of 5 employees. We calculate their mean, and then we denote it by x bar. Then we subtract this mean from each value, like 12 minus mean will be minus 5, 20 minus mean will be 3, because mean here is 17. Then we take the square, add them up, but here we will divide it by n minus 1, 5 minus 1, 4. We divide this sample variance by n minus 1 instead of n, because sample may calculation made on the basis of sample may overestimate the variance, may underestimate the variance of the population. Just to overcome that problem, we divide it by n minus 1. And if we take its square root, we will get the standard deviation. Thank you very much.